In question 1, we have to multiply these two numbers that are in scientific notation. So the approach that you can take here is multiply the 5 and the 6 together, and then multiply 10 to the 12th and 10 to the 18th together. So you're comparing similar parts. 5 times 6, well, that's definitely 30. But when you multiply 10 to the 12th times 10 to the 18th, you can simply add the exponents since the base is the same. So that's really 30, and then we have 10 to the power of also 30. And our standard notation of writing this was, well, you put 30 times 10 to the power of 30. But there is an issue here. The problem is this number must be between 1 and 10, strictly less than 10. And currently, it's greater than 10, so we have to make an adjustment. What we're going to do is decrease that number, 30, down to 3. But if you make that smaller, that means you also have to change the exponent. We're going to increase it by 1 to 31. So, I'll write this again, but that's 3 times 10 to the power of 31, and that is the final answer. For question 2, we're supposed to graph the line 2x plus y is equal to 6, and from our graph, identify the slope, x-intercept, and y-intercept. I think our approach of, well, if we let x equal 0 in the equation 2x plus y is equal to 6, it'll be very easy to solve for y. So that is, if I put 0 in place of x and leave y alone, my equation becomes y is equal to 6. That means the point 0 for x and 6 for y must be on the graph, and I'll plot that here. I have to do the same thing for y. If I let y equal 0 in the equation 2x plus y is equal to 6, it'll make solving for x very easy. We get 2x plus 0 is equal to 6. And since 2x equals 6, after dividing both sides by 2, we get that x is equal to 3. So that's the point 3 for x and 0 for y, which I'll mark right here. And my graph is the line that goes between those 2 points. So just to get a basic sketch of this thing, I get this as my graph. Now that we have the graph, I want to identify the x and the y-intercepts. Since this is the y-axis, it must be that this is the y-intercept, which referred to this point here. So I'm going to label this as the y-intercept, y-int. And therefore, this other point has to be the x-intercept, but that makes sense. This is the x-axis, this is the point on the x-axis, so again, that is my x-intercept. And the last thing would be the slope, which we define to be the rise over the run. If I start at this point, I have to go down 6, so my rise is actually a negative number. It's negative 6. And then I go over 3, so that's positive 3. And if I simplify this, I get negative 2 over 1, or simply negative 2.